So here's high bay 1, and then high bay 3. We really, they took out all these platforms. I'm going to step down. See the shuttle pads, 39B and 39A.
Wow.
Okay, so officially welcome to the space chat. I ask all the participants to be muted, and later we will give the audience the possibility to ask questions. Please write them in the Zoom chat. You find that in your window. And now I'd like to introduce our guest, Kelvin Manning. Kelvin Manning serves as Associate Director Technical of NASA's John F. Kennedy Space Center in Florida. In this capacity, he is responsible for ensuring safe and effective execution of the center's technical capabilities, including establishing strategies and policies to ensure the Kennedy workforce, facilities, and operations are aligned to facilitate agency program and project goals. Kelvin Manning obtained his Bachelor of Science from the US Air Force Academy in Colorado Springs. In addition, he has a Master of Science in Industrial Engineering from the University of Central Florida in Orlando. And he has completed the Senior Executive Fellows Program at the John F. Kennedy School of Government at Harvard University. As an Air Force officer, he served at Eglin Air Force Base in Florida and NORAD Cheyenne Mountain in Colorado Springs. Following his military service and prior to joining NASA, Kelvin was an engineer with General Electric's Aerospace in Springfield, Virginia, and McDonnell Douglas Space Systems Company in Washington, D.C. Kelvin Manning has received numerous awards, including the Presidential Meritorious Rank Award, the NASA Exceptional Achievement Medal, the NASA Exceptional Service Medal, the Astronaut Silver Snoopy Award, and many more. The Swiss Space Museum is delighted to have Kelvin Manning as a special guest for today's online chat. Welcome, Kelvin.
Hey, thank you very much, Guido. And hello, everyone. Good afternoon, good evening, depending on where you are. It's great to be here. Well, I was going to start off with a video of my own and a presentation to show you where we are at the Kennedy Space Center. You could bear with me while I get it set up here. Okay, are you seeing the picture?
Yep, works.
Okay, I'll kick it off with a video. So I hope you enjoyed that. We really have done tremendous amount of work since the last flight of the space shuttle. Atlantis landed at the shuttle landing facility on July of 2011. It's over 9 years, and we have truly transformed the Kennedy Space Center into what we call a multi-user spaceport. So just showing you some of what we have going on here. I'll start in my left-hand corner on the top of the screen. This facility operated by Boeing, we call it the C3PF, or Commercial Crew and Cargo Processing Facility. That's where the work is being done on the Commercial Crew CST-100 Starliner. Below that, Boeing is partnered with the Air Force in what used to be one of our Space Shuttle Orbiter Processing facilities. Now that's the home of the Air Force's X-37B orbital test vehicle, and that work is going great. Here in the upper center, what used to be the shuttle landing facility is now operated by Space Florida, a state agency, and they call it the Launch and Landing Facility, hopefully bringing horizontal launches and landing to the Kennedy Space Center. Next, you see SpaceX, a picture of Launch Complex 39B. That's where they launched their Falcon commercial missions from the NASA side. They also have a pad, Launch Complex 40 on Cape Canaveral Air Force Station, but this is the pad where we launched the Commercial Crew mission. Same pad that we launched multiple space shuttle missions, as well as Apollo, where we went to the moon, came off of 39A. Below that, Lockheed Martin is operating out of the Neil Armstrong Operations and Checkout Facility, processing the Orion spacecraft, which includes the European Service Module, European Space Agency Service Module. You see that there. Below that is pointing to Launch Complex 36, and that's another one of our partners, Blue Origin. They plan on launching their New Glenn rockets there. And then in the bottom corner here, the picture of Exploration Park, where Blue Origin also operates out of that area with a massive rocket manufacturing facility that they're building there. Also, they'll be joined by Firefly Aerospace, and OneWeb Satellites also has a manufacturing facility there, and that's all managed by Space Florida. Totally, we have just under 100 partnerships with under 300 different agreements with private, public, academia, multiple partners. So we are looking really well into the future. Just a glimpse. This picture is supposed to tell you the 5-year forecast, if you will, looking out at the significant amount of launch activity we have going forward. And this summarizes it with the numbers. Kennedy is the home of these programs, and I'll touch on them briefly in future slides, but you see the Commercial Crew Program, Launch Services, Exploration Ground Systems, Gateway, and our Exploration Research and Technology programs. Some of our key milestones last year, I'm not going to read each and every one of them because I'm going to highlight the major ones going forward, but you can see there was a significant amount of activity. And then this year, you see the check marks of where we are. We've actually launched the Mars 2020 there, and it's on its way to the Martian surface. I have a slide on that, and I'll keep going. So Commercial Crew, you know, this is, hello?
Yeah, you're still here.
Okay. So Commercial Crew, this is our plan to return U.S. astronauts on a U.S. spacecraft launch from the U.S. soil, so we don't have to rely on our Russian partners for launch. And of course, on our way to our successful Demonstration 2 mission, we launched Demo 1 last year. This was a test flight of the Crew Dragon, unmanned, of course. And then there was also the in-flight abort test we had earlier this year. You pay attention to the video right at around 1:37. You can see the crew capsule separate and the rocket will explode right there. But that was a crucial test leading us forward to launch people. In the unlikely event of a abort, the the spacecraft is designed to separate from the rocket, and the astronauts would parachute safely back into the water for recovery. And then there was the actual Demo 2 mission, launched in May, and Doug Hurley and Bob Bankin, we brought them back, splashed them down in the Gulf of Mexico, the west coast of Florida in August, and that was very successful. And then late last year, Boeing had their OFT, orbital flight test. Unfortunately, it wasn't able to dock with the space station because of some software errors, but still a lot of the key objectives were met, and we look forward to the reflight of OFT2. So Artemis is NASA's program to return to the moon. Artemis was the twin sister of Apollo, known as the goddess of the moon. The Artemis program is anchored by 3 major programs: the Space Launch System rocket, the Orion spacecraft, and Exploration Ground Systems. And again, Exploration Ground Systems is headquartered at Kennedy. So EGS, Exploration Ground Systems, we're responsible for providing the infrastructure to support the SLS and Orion launch. You see the crawler transporter in the corner here. That was the same CT that we used in the Apollo era, but after major refurbishments to carry the heavy load of SLS and Orion out to the pad, it's essentially brand new. What you're looking at here is the Pathfinder of the SLS core stage, and I'll show you another slide on that coming up. Major accomplishment last year was the Orion Ascent Abort 2 test. That was the in-flight abort test launched off of Cape Canaveral Air Force Station. And there it goes, separating from the booster. As I mentioned before, Orion is processed in the Neil Armstrong Operations and Checkout Facility, and there's the crew module as well as the European Space Agency service module, which make up the spacecraft. You're looking at a high-speed video of getting ready to roll the spacecraft out to transport to Plumbrook that happened last year so they could do some vacuum testing. And just capturing the video of when the Orion spacecraft returned back from Plumbrook, and that's in Ohio, outside of Cleveland in the United States. Part of the ground processing also involves the segments, the 5-segment solid rocket motors used for the Space Launch System. And we're practicing the processing, and the RPSF is another acronym, the Rotation, Processing, and Surge Facility. And in the vehicle building High Bay 3, what Guido showed you in his opening video was looking down in that high bay before those 10 platforms were put. What Guido showed you in his opening video, this is how it looked today. And we can't wait for the rocket to arrive where we could start and for processing that for the Artemis 1 mission. This is that core stage Pathfinder I mentioned, and the Pathfinder was brought to Kennedy Space Center so we could practice this is how it looks today on this 1 mission. It's approximately, this was that core Pathfinder I mentioned, about 212 feet, and I think that's around 27 feet wide, just over 8 meters wide. So it's a monster of a rocket. And the actual rocket, after it was built at the Michoud facility in New Orleans, Louisiana, it was transported via barge to the Stennis Space Center, and we're preparing it for the green run, which is a test run of the rockets, and the rocket engines are essentially reused from the shuttle program, the RS-25 engines, which in the shuttle era we call them the SSMEs, Space Shuttle Main Engines. Beautiful picture. Then the mobile launcher, this is pad 39B. This is where we will launch SLS and Orion, and the mobile launcher will carry the SLS and Orion out to the launch pad. That whole gray structure is carried out by the crawler transporter with the rocket. It's approximately 21 million pounds rolling down the road, and then mounted atop the launch pad for the launch. Those big towers you see, those are actually part of a lightning protection system, and they're all connected by what we call a catenary wire, trying to give the rocket inside of there a cone of protection, and when we launch, it goes right through the middle of the wire. Part of the exploration ground systems, of course, the Launch Control Center. You're seeing a picture or a video of our launch director, Charlie Blackwell Thompson. She will be the Artemis 1 launch director. In fact, just this week, Monday and Tuesday, we did a launch countdown simulation, and that's what you're looking at there, the team preparing to launch SLS and Orion. Gateway Deep Space Logistics, let's see a short video there. So what that was showing was the different elements of the gateway. Gateway is essentially a lunar outpost orbiting the moon in a roughly 6 to 7 day period in a near rectilinear halo orbit that will give us sustainable access to anywhere on the moon. But we'll focus initially on the South Pole. Then the launch services program I mentioned, the manifest. We launched Solar Orbiter, partnered with ESA earlier this year. Again, Mars 2020 was launched just a few weeks ago. And on November 10th, we look forward to the Mike Freilich launch, which will teach us about the ocean levels. And LSP, Launch Services Program, also provides the advisory services to the programs you see below. And here's a short video to capture that.
Kelvin, somehow the connection is not very good. For the video, it might be a little bit.
Oh, really?
Yeah. Or maybe you can jump over the video.
Do you want me to skip it?
Yeah.
Okay. Yeah, sorry about that. That was, again, capturing the Icon launch, Mars 2020 upcoming Sentinel-6 launch. In our final program at Kennedy, we have the Exploration Research and Technology programs where we do plant research and food production work to support the astronauts on the station. You see the picture of the International Space Station, all the space station logistics and payloads. Many of those that are launched in the U.S. are processed through our space station processing facility at Kennedy. We do work with in situ resource utilization. You see our Swamp Works logo with the excavator in our regolith bin. And again, plants grown on Earth that we're flying up and actually growing on this space station that will be important for long duration space missions. So that was pretty much all I had. I wanted to, extend a welcome. If you're ever in Central Florida, please come visit us. The Kennedy Space Center Visitor Complex is listed as one of the top 10 museums in the entire United States, and I guarantee you will not be disappointed. And finally, just wanted to say, Dr. Shane Guido, thanks for the opportunity to participate in today.
Thank you for this introduction. So,
finally, participate in today's event.
So I have, of course, a lot of questions that they won't fit all into my interview. But first, I would like to know from your side, Kelvin. Wait a second. Do you remember how and when your interest in spaceflight began?
Well, I think as a kid, like a lot of kids, looking up at the stars, I was always, interested in space. When Neil Armstrong walked on the moon, so that was, July of 1969, I was actually 10 years old. But at the time, my father was serving in Vietnam, and I asked my mom, I said, Mom, did I get to stay up to watch that landing? She said she couldn't remember, but I think I was in bed because I was like a rascal of a kid.
So you were born in Fort Meade and as an army brat, and you traveled a lot around. You resided in Texas, New Jersey, Indiana, Hawaii, Illinois, and Maryland. To what extent did this childhood prepare or shape you for your present job at the Kennedy Space Center?
So I think as military brats, that's the term that they use for, people whose parents are in the military. You do so much traveling around. So you have to have the ability to make friends and, when you're coming someplace or somebody else is coming in. So that ability to get along with others and make friends, I think has developed me has shaped my personality where, that's assisted me in my career working at NASA. When somebody hires on for their first day, I tell them two things. You got to be the best that you can be, that subject matter expert in your discipline. And the second thing is the ability to work well with others is so important.
So during your time at the Air Force, you already specialized in space operations. What made you decide finally to start a career in the space sector?
Well, I think, as a kid, there weren't too many people that looked like me. I'll say just straight up African Americans in the space program. And, it was something that I didn't know I would have that opportunity. But then being in the military, I had 10 years of space experience, or 10 years, 6 years in the military and 4 years in industry. And then, I was looking for other opportunities, and I just saw something for NASA, and I said, hey, I've been doing this for 10 years. I could maybe work for NASA.
And then you started your job. Many people dream of working for the Kennedy Space Center, and you have started your career there 28 years ago. How did you get involved?
Yeah, it was having that background in the military, and then that allowed the door to be cracked, if you will, and working my way, learning different programs, different systems with the space shuttle. And advancing to higher positions, it's just been a dream come true. Now we look around and we say we don't have any more adult supervision, so we're running the place.
That's cool. So when you started working at the Kennedy Space Center, the shuttle program was in full swing. Can you please tell us a little bit how the atmosphere at the Cape was at this time?
It was incredible. With the multiple space shuttle orbiters and constantly, launching one. It wasn't every month, but it was kind of every other month or sometimes, twice a month. Just that tempo and that camaraderie of, doing something big, launching people into space and bringing them back home is just such a huge accomplishment. And when everything's going right, I think there's just no better feeling.
During this time, you worked within the former Shuttle Processing Directorate. You were flow director for Space Shuttle Atlantis. You were chief engineer for shuttle upgrades, and you were NASA test director. Which of these jobs were the most important responsibilities from today's perspective?
Being a flow director was my dream job. It was the highest grade job, being the leader of the processing team responsible for a specific space shuttle orbiter, getting it ready to fly. That's still my favorite job that I've had at the Kennedy Space Center. It was the best job for sure.
You also were vehicle manager for the Space Shuttle Columbia. In 2003, Columbia was destroyed. During the re-entry, all 7 astronauts died. How did you experience this accident?
Yeah, that was tough. So, I was the vehicle manager for Columbia for 6 flights. I think that ended in 1999 when I went to JSC for detail, and then I came back to be the Atlantis flow director. But Columbia, was the very first space shuttle orbiter we had in the agency, and it held a special place in my heart and many people's heart. And to lose an orbiter and the crew was just devastating. These big, huge pieces of machinery were like they had their own personalities. And when you lost the orbiter, it was like losing a member of your family. And with the crew, it's just, it was really tough.
I read the book about Columbia written by Jonathan Ward. It was really interesting to see how big this operation was to recover Columbia and all these things.
Yeah, I was out there for 3 weeks. Part of the recovery, I worked in Lufkin, was the command post, and got to visit each one of the collection sites. And they actually let me walk a day down in Hip Hill, with one of the team of firefighters looking for pieces of debris. But I tell you what, coming back and all that, debris was put together, laid out on the floor in one of our hangars. To see that vehicle like that, where part of my job every day, we call it walk down the vehicle, all the platforms, and just check out what was going on, and to see it scattered in pieces was just, really hard.
I can imagine. What was the most important lessons from this accident, from your perspective?
It's the importance of communication and listening to ensure that everybody is heard. We talk about inclusion, and inclusion is make sure you have everybody at the table, say for a meeting, and again, everybody has an opportunity to talk, and everybody has an opportunity to be heard.
Towards the end of the shuttle program, the Constellation program followed. There you served in the Kennedy Constellation Project Office. constellation, by the way, was the program started under President George W. Bush in 2004, and the goal was to return to the moon until 2020. And then in 2009, the program was cancelled by President Obama due to exploding costs for this program. Such plan changes occur repeatedly at NASA. How hard was it for the workers at the Cape when the program was stopped?
It's very demotivating. You spend a good portion of your life working on something, and there's a lot of we say blood, sweat, and tears put forward. And at the end of the day too, we at NASA, we have to look in the mirror. We have to deliver. We have to deliver a quality product on schedule and within the budget. And that's the message that we keep carrying forward today. As the American Congress and the president have, put faith in our program to return to the moon and then on to Mars, it's incumbent upon us to deliver.
Okay, so after Constellation, the program changed completely. There started these commercial programs, and what changes have they brought to NASA and to the Kennedy Space Center?
I would say it didn't change because Orion was part of Constellation, and we were able to reutilize or repurpose Orion to be part of Artemis. And then on the ground systems, our mobile launcher that we were using for Ares 1, the Ares 1 rocket was part of Constellation. We were able to rework that, and that's the basis of the mobile launcher. You'll see that will launch Artemis 1. So that was able to stay. But the whole mindset of going to commercial partners, that was a whole new paradigm for a lot of people. And looking at where we are today after the successful demonstration 2 mission, I think it's opened up a lot of people's eyes. You look at the cost savings for one, and just the possibilities for the future as we return to the moon. Those partnerships, commercial partnerships and international partnerships, I think that will pave the future for us continuing to move forward with a sustainable solution.
You mentioned now the Demo 2 mission that was launched on May 30th this year, after nearly 10 years during which the USA was dependent on the Russians. How important was this launch for you?
It felt so good. And there's a one thing about not having that capability, but it affects people differently. But as an employee at the Kennedy Space Center, where we launch people, and not having that happen, it was definitely a void. We launch satellites and different other payloads all the time, but when you put humans on top of a rocket and launch them, that is a tremendous responsibility. And that's something that, this team just lives for.
The launch was done by SpaceX, and this is one of the partners you mentioned, which is now at the Cape. I can imagine that some of our people in the audience ask themselves if you ever met Elon Musk. Did you, and how was it if you met him?
Well, I'll tell you, I've only seen him at a distance. I have never personally met him. My job, I'm more of a behind the scenes kind of guy. So I support our director, Bob Cabana, and the deputy, Janet Petro. My job can be described as anything they don't want to do or can't do or tell me to do. But like meeting Elon, no, I haven't had that pleasure.
now the Demo 2 mission was really successful. We could all follow that. How will manned flights now continue in the next few months?
Okay, so Guido, I would correct you when we say human flights, right? Because we fly men and women aboard the rocket.
Sorry for that. Thanks for the correction.
Yeah, just giving you the business here. Hey, so we have the last NASA astronaut going off of a Soyuz rocket. Kate Rubins is out there in Star City right now, and that launch, I believe, is scheduled for October the 14th. And that should be the last contracted launch on a Soyuz, at least for the time being. And then right now we're planning for the Crew 1 launch, which is slated for no earlier than October the 23rd. And we will launch 4 U.S. astronauts. Do I get that right? Yeah, or 3 U.S. astronauts and 1 Japanese astronaut on Crew 1. And you know, that is just so exciting. What I talked about earlier about returning human spaceflight back to the space coast of here in Florida and back to the United States in general, that is just such a big deal for all of us.
Now, NASA also has very big plans. You also mentioned it in your overview, the Artemis program. Once again, the goal is the moon. What are the plans and what are the big differences between Apollo and the plans for the Constellation program and now the Artemis?
Okay, so Artemis is, you know, we want a sustainable presence on the moon. You know, we say we're going to the moon to stay. And if you look at Apollo, so in the history of humankind, only 12 individuals have walked on the surface of the moon. And if you read, you study about those missions, you'll learn about these harrowing adventures just trying to make it happen. And you know, now it's like, oh yeah, we've been to the moon, and it was you know, nothing close to being simple. But for us to do it again and have that sustainable presence so we can learn about the moon, learn about, you know, how to use that lunar ice to make rocket propellants and eventually go to Mars, you know, I think that's what we live for. You know, we're here to explore.
So there came up a question. I just put it in here, and of course the Artemis program is very sporty. The goal is to land in 2024. How realistic is this date?
Yeah, like any other major program, it all depends on the budget support. You know, there's a quote from the movie The Right Stuff. No bucks, no Buck Rogers, right? And so you know, we're moving forward. Before we can make 2024 an Artemis 3 landing on the moon, we've got to do Artemis 1, and that's what's, you know, smack in the middle of our radar, trying to get that Artemis, trying to get the core stage to the Kennedy Space Center, and get that process, get it mated with Orion, and hopefully launch that by next summer sometime, at least by the end of next year, 2021. That's the goal.
So I also ask myself, what precautions are in place to ensure that the Artemis program will not be terminated like the Constellation program if there is a change of government?
So after the Constellation program was canceled, one of the major takeaways that the agency had was we need a flexible architecture. We need an architecture that will enable us to go to the moon, to Mars, wherever, you know, and these piece parts give that flexibility. Bringing on the commercial partners, you know, is another major step. Not only is it adds to the flexibility, but the sustainability with the cost savings that some of the commercial partners can bring.
There is, you also mentioned the space launch system. This is really a huge rocket they want to build. what is different to other rockets NASA could use? Like, for example, the Falcon Heavy. Why don't you use this and not the Space Launch System?
I think the space launch system has the greater capability, the lift capability. You can do things with a single launch versus multiple launches. I'm not discounting the Falcon Heavy as having a role in our future exploration. And I tell people, give it time as we move forward and see how things unfold. Things change all the time. But it's exciting that we have options for sure.
And as we heard, the Orion capsule will be on the top. You've been selected as the first division chief of NASA's Orion spacecraft. What was that job you have done there?
Oh, so that was, I guess that was in the early 2000 time frame. And that was serving as the primary interface between Kennedy Space Center and Johnson Space Center, where the Orion program is managed at a Johnson Space Center. So all those critical interfaces between the rocket and the ground systems, that was my job, to be that bridge between the ground processing side and the flight side.
And now, let me see. You also have served on the last two NASA astronaut candidate selection boards. So I guess this was really an interesting job. What skills do you think a candidate must have in order to be selected as an astronaut?
And Guido, before I start, I'm on this current astronaut selection board now, so it'll be like 3 times in a row, the class for 2013. 2017 and the class of 2021. So, what does it take to be an astronaut? It's, amazing. This year we had over 12,000 applicants to be an astronaut. Last year we had, the last class, we had the most in the history of NASA. 18,360 some people applied, and we picked 12. And so, you have to have the academic background. This was the first year that we said we required applicants to have a master's degree. And we're looking for, the technical fields, the STEM applications, related degrees, science, technology, engineering, and math type of focus. And you have to be physically fit, of course, to endure the rigors of space flight. But the number one criteria that we're looking for that is not so easily, determined from reading somebody's application or a resume is, again, the ability to work well with others. If you think about it, if you're going on a long duration space flight mission to Mars, you're going to live on the moon in tight quarters, you want people that can get along, and if you look at the last 2 classes that we picked, we just picked a great group of men and women, some of the best people that you'd ever meet. And, you wouldn't mind spending time with them, just having fun, and super smart.
So I bet they won't act like in the newest Netflix series where they have fights on the way to Mars.
Hopefully not.
Did you ever want to become an astronaut?
I didn't even think it was. I didn't even think it was possible, to be honest with you. And the last selection board, they said, "Kelvin, you should apply." And I think I'm too old now. Although there's no age restrictions.
You mentioned all these 18,000 people who applied. In the board, you have to make the decisions who will be selected and who not, and only a few will make it. How hard is it to destroy these many dreams?
Yeah, that's pretty brutal. So we actually, they bring in 120 to get an interview. And of that 120, roughly half or so come back for a second interview. And it is tough. you know. But at the end of the day, we're picking, the best of the best, and not everybody can, it's not practical to have huge numbers of people to be an astronaut because of the cost with the training and stuff. But if someone's not selected, of course, they're encouraged to apply again. Bob Cabana, director of the Kennedy Space Center, my boss, I believe it took him 3 tries to get in.
So you never should give up.
Right.
I just want to come back to my intro video I showed. This was in 2012 when we went to the top of the roof of the famous vehicle assembly building. What is your favorite spot at the Kennedy Space Center?
Yeah, that's a good question. I'll tell you, my favorite spot is no longer there. When we had the shuttles out at the pad, or when the pads were configured for the shuttle with the fixed service structure and the rotating service structure, I would go up to the 275-foot level and go on a platform and overlook the space shuttle at the pad and see the ocean up and down the coast. That was pretty magnificent. And to be out there and say, hey, I'm getting paid to do this, that was really cool.
So now we have time for some questions from the audience. We already received some. One is from Lajos Lang. He asks, how much did Corona influence NASA?
How much did Corona influence NASA? So I don't know. I probably need some clarification with the Corona that he's talking about.
Well, I guess he wants to know if programs have changed or the work has changed because of the coronavirus. Of course, you are.
Oh, I understand. When because there was an earlier space program called the Corona program, and my mind was in the space mode. The coronavirus, yeah. Hello. That has, it has constrained things, but at the same time, we launched Demonstration 2 mission during a pandemic. We launched Mars 2020 during a pandemic. People are working at home and probably haven't been as or let me put it this way, have never been as busy before. We're getting a lot accomplished despite the pandemic. And I think a lot of that is just that NASA culture, that can-do culture. And we've been the best place to work in the United States government for large federal agencies for 8 years in a row. And I think people are just so psyched about the mission and what they can do to contribute to mission success.
Okay. You talked about the can-do culture. There fits a funny question from Dirk Noy. He asks, in the background, you have this T-shirt with the Nike on it. Is Nike now an official sponsor of NASA, or is it the other way around?
No, I got that. I saw that shirt online, and it was I just thought it was cool because the Nike slogan is "Just do it," right? And you see the NASA worm. We brought the worm back into our workplace, if you will. The worm was on the side of the Falcon 9 rocket for the DM2 mission, and then of course the NASA meatball. I just love that shirt, so that's why I hung it up there just as a prop.
Okay. So we have another question coming from Tanya. Firstly, she thanks you for the interesting information, and she asked, could you describe how a usual workday looks for you and what you do exactly the whole day?
Hey, Tanya, that's a great question, and sometimes I wonder about that myself because in my position, I do a little bit of everything. To keep the center running, and the Kennedy Space Center is like a city in itself. We're over 400,000 acres, which is about 567 square kilometers. And a lot goes on. We have our own, police department, our own fire department. There's the environmental piece. We share the land with the Merritt Island National Wildlife Refuge and the Cape Canaveral Air Force Station. So people ask me, what do I do? I say, well, I keep the wheels turning, the lights burning, the workforce churning, so the rockets are flying, politicians buying, satellites soaring, astronauts exploring, so the kids will learn and the public will yearn for America's space program. So, yeah, I go in sometimes thinking I'm going to do one thing, and I get redirected in a totally different direction.
Okay. Let me see if there are other questions. Maybe they come up. Otherwise, I have one from my side. As I mentioned earlier, you during your time as an Air Force officer, you worked at NORAD. Soon it will be Christmas time, and of course, I wanted to know if you ever tracked Santa Claus.
Oh yeah, that was a big deal every year. When I worked at NORAD, I was an orbital analyst, so I dealt with satellite orbits. So yeah, we would track Santa and his sleigh, and bring those reports in from around the world.
I have another question from Dirk Noy. Does the lunar recipient lab from the Apollo era still exist? Where all the material came back, the lunar rocks, this stuff?
They sure do. So those resources, I'll just put it that way, are located at the Johnson Space Center.
Okay.
It's something I've never seen personally in my career. I have to make it a point to get a tour of that facility. But yeah, they're in I want to say Building 2 at JSC.
Okay. Let me see if there is another question. No, not yet. So we are early. There's the last chance for everybody who is online to ask a question to Kelvin Manning, if there's something. Here, do you measure sound pressure levels during launches?
I don't know if we currently do, but I know we have done in the past to capture that data, and we're always concerned on how we're interacting with the environment, and that sound data is an important component of that.
So, do you know the approximate levels of a launch? For example, from Falcon 9?
No, I don't. Yeah, I don't. I don't know if that. I know for the space shuttle, you could probably find that online. That's probably relatively readily available. But for the Falcon 9, I don't know if that data is out there.
But definitely loud.
Right. And the space shuttle, if you were within a certain, like really close, that the sound was so loud, it would it could kill you, that loud.
So you shouldn't go too close. Not like in the Apollo 13 movie where the actor was very close to the Saturn V rocket that launched.
Yeah, I remember that. It's like, nah, that wouldn't happen.
Okay, so if somebody has a question, you can also open and unmute if you want. Rodri, you can unmute and ask your question if you want.
I'm here, thank you. Just a question, well, maybe not an easy question, but has in the 70s, America and Soviet Union were still able to do a joint mission, to cooperate, to exchange information, technologies, and so on. Do you think maybe one day also America and China will be able to cooperate some way in the space, in the space technology, space industry, or space missions, or whatever?
Yeah, I would truly hope so. You know, back there in the Apollo Soyuz test program, that was something that people thought was impossible. You remember because of the space race of the 60s. And then when the American crew met the cosmonauts on orbit, that was just a remarkable accomplishment. So when astronauts on orbit, you know, the common thing they always talk about, they look down on the planet and they don't see any borders. And, you know, we're all in it together for all practical purposes. And, you know, the US and the China, that would be awesome if one day we could be partners, you know, if they could join, if China could join the rest of the international partners and, you know, help us get to Mars.
Thank you. Anybody else who has a question? Yeah, you did. Just unmute. You can ask.
Yes. Hi, everybody. my name is Marco. Kelvin, it already takes a lot of time to go just to the moon again. What do you estimate will be the time frame to go to Mars? That's my first question. And the second one, we have very little experience, only maybe half a year, what the space flights do to human bodies. So what can we expect, and what will be the problems to go to Mars, which takes far more time?
Yeah, the way it's laid out with some of the scenarios that folks have been working on, they see the Martian missions being pretty much a 3-year round trip. You know, approximately a year to get there, the surface time, and once the planets realign, you know, it'll be 3 years when the whole thing is done. So that, you know, long duration space flight, that's, you know, why we continue to justify the International Space Station. You know, the longest a U.S. astronaut's been on there is just under a year. Russians just almost exactly a year. Dealing with space radiation, you know, that's a challenge. How do we protect our astronauts to and from Mars, as well as on the Martian surface, without the lack of the atmosphere to protect the astronauts from the radiation? And those are all real challenges. Plus you know, just the physical distance. If we say the moon is approximately 250,000 miles away and Mars can be 35 million miles away, it's hard for me to get my mind wrapped around that and what that's going to mean, because it's not a trivial matter.
And do you think we will see a Mars mission in our lifetime?
I hope so. You know, I hope so. You know, we've been saying in the 2030s for a long time. You know, we gotta, what again, I mentioned here, and what I continually, you know, reiterate with our team is we got to make Artemis 1 happen first. You know, we got to take that first step and get that big rocket, and then Artemis 2, and then get back to the moon. We got to make that happen. And then, you know, those incremental steps will eventually get us there. But right now, you know, we haven't been to the moon since 1972. So it's just unbelievable, crazy that, you know, that hasn't happened.
We have a last question from Dirk Noy. Dirk, you can unmute you.
Yes, I'm in a loud neighborhood with all kids running around here, so I apologize for any disturbances optically or audio-wise. But thank you so much for your contribution. I'm sorry to be late to the game, but I was wondering, can people still buy tickets to get to space, like commercial tickets, or is that over now? The US has their own program back again, basically.
So I know, you know, the Russians, you can still buy a ticket aboard a Soyuz. I don't know, you know, how many, you know, millions of dollars that's going to cost. But, you know, part of the commercial crew program that we've been sponsoring is for our commercial partners to fly, you know, private individuals. So sometime in 2021, I think we will see a private mission going up with non-NASA astronauts, launch from the Kennedy Space Center to the International Space Station. So that'll be huge. They just named one company, Axiom, which will be a customer, named a former NASA astronaut, Mike L.A. Lopez Alegria, to be the commander of that mission. So, you know, we're moving, I guess, as a, you know, humanity is moving forward to having you know, government astronauts on a regular basis. Blue Origin, Jeff Bezos hands on eventually opening up the commercial suborbital flights on the New Shepard launch vehicle. That'll be happening. They hope to launch people as well from the Space Coast here in the upcoming years. And then there's Virgin Galactic. You know, they're still, I can't remember the name of their vehicle, but, you know, still looking at private suborbital flights.
Spaceship Two or something, isn't it?
Yeah.
The one that
Yeah, correct.
touching and then coming ballistically back to Earth. I'll start saving then. Thank you for the information.
And we
Yeah,
heard,
that was cool.
and we heard from the private person, Tom Cruise, who will fly, who should fly into space to make his next movie. We could read that.
Yeah, that's Elon and SpaceX. You know, they're working on that with NASA to make that happen. But
It's
you
a big
know,
ad for SpaceX, basically. Sorry for interruption.
I remind people. So when Doug Hurley and Bob Behnken just flew, you know, that for practical purposes was a test flight, right? First human flight on a new vehicle, and there's nothing trivial about flying into space, and it's still, you know, very dangerous business. So yeah, you know, I think we got a few more flights, a lot more flights before you would consider it to be operational.
Okay, we are already over time. Kelvin, thank you so much for all these interesting insights. It really was a pleasure to have you on our show. I hope you enjoyed it too. And
very much so.
We let you go back to your work. You still have a few hours to work. So we heard you never know what you really do there. So enjoy your work. And then have a great weekend. Thank you so much for your presence.
Oh, my pleasure. Again, Dr. Shane, like I said, and hey, stay tuned because we're just beginning, and it's a very exciting time for spaceflight, for human spaceflight, and really looking forward to an exciting future.
Thank you so much. Goodbye, Kelvin. And goodbye to the audience. Thanks for being with us.
Thank you. Bye-bye.
Okay, bye-bye.